there's another thing I want you to remember. I don't want to get any messages saying that we are holding our position. We're not holding anything. Let the Hun do that. We are advancing constantly, and we're not interested in holding on to anything except the enemy. We're going to hold on to him by the nose, and we're going to kick him in the ass. We're going to kick the hell out of him all the time, and we're going to go through him like crap through a goose. No. There's one thing that you men will be able to say when you get back home, and you may thank God for it. 30 years from now, when you're sitting around your fireside with your grandson on your knee, and he asks you, what did you do in the great World War II? You won't have to say, well, I shoveled shit in Louisiana.
Okay, good afternoon, everyone. It's the end of the day, just light it up, all right? We are in a once-in-a-century digital revolution, so you guys are lucky. There's big bucks to be made. I just hope everybody study hard, work hard, make a lot of money, and rise up to all the challenges. So 30 years from now, when your grandson asks you, what have you done in the great digital revolution? You don't have to say, I shoveled shit in somewhere. Anybody from Louisiana, by the way? Good. Okay, today we are going to cover a rather difficult and complex issue. So I really thank everybody come to this difficult class. Give yourself a little applause. But don't be scared with all these acronyms, all these technical terms. At the end, you will find out the logic is very simple, the conclusion is very simple, so very easy to understand. So if you have any numbers you kind of have difficulty to comprehend, skip it, just grab the main concept. Let me ask, how many of you guys are using HDMIs in the daily jobs? Everybody, right? How many of you guys think HDMI is perfect, trouble-free, reliable? Good. That's why we are here. Okay, so here are the topics we are going to go through. Many HDMI problems are related to what we are talking about today. And hopefully we can go over the HDMI basics and cover the HDCP, EDID, DDC, I2C, that reads as I2C. Don't be scared, it's very easy to understand. Then once we understand all that, then we understand why we are running all these into these problems. Then we can solve them easily. So we'll have a HDMI troubleshooting session. Then we also have discussions to have everybody share the experience. That's why we come to the trade shows, right? And also, I don't want everybody to save your questions to the end, because discussions will be one after another. It's like a chain. If you get lost with somewhere, it's difficult to follow up. So anywhere you have questions, raise hand. I'll stop right away. We have discussion right there, clear up, then we'll move on. Okay? Make it a truly interactive session. This is myself. Anyone try to read my first name? That's so good. That's so good. 20-some years ago, when I came from China to the US, I worked for Extra for many years. They practiced how to read my name. Then they called me in the first day when I worked there. I didn't know what they were talking about. That's why I'm known for everybody as my last name, Lu. I challenge any of you guys have a shorter name than me. So just, you're welcome to call my last name Lu, very easy. Okay, I'm the founder of Lu Engineering, which is a patent and a training company. Also Lux Electronics, which is a professional audio-video product manufacturer. We have a booth 2403, if you want to write down, right at the main entrance next to Sony. You guys are welcome to see what we have in there. I've been in the industry, I show my age now, 31 years. Actually, I've been making the electronic gear since I was 11. So professional for 31 years, amateur more than that. I'm the author of the white paper, HDMI Demystified. Anybody have read that? Not a whole lot. That was published like 14, 15 years ago when the HDMI was just introduced. At that time, because it's so new for digital, a lot of people didn't get the concept. So many journalists, they know half of the story. So they publish all kinds of articles saying you get a $5 Fry's electronics cable and the $200 Monster cable. They do the AB switch to the monitor. They see no difference whatsoever on the monitor, which is true. So that made all the premium manufacturers panic. How are you going to sell digital when you cannot see the difference? So in that white paper, I outlined there are many ways of testing digital products, which is different from the analog. I patterns, you guys heard that. Bit error rate testing, you guys heard that. More importantly, I introduced a system called speed rating. So for the same 2-meter cable, even you only need 4 gig for 1080p, but the good quality cable can go up to 50 gig. The cheaper one can only go to 6 gig. So even you cannot see any difference on screen, but there's performance difference. Why it matters? Because now I have 4K, I have 8K. So if you have a cheap cable you sealed inside a drywall, then 2-3 years later, when the signal upgrades, you have to knock open that wall to change to a better cable. So you end up buying 2 cables and 2 labors. You could have done just with 1 good cable, 1 labor in the beginning. So that concept is called future-proof. That's also outlined as a marketing strategy in that white paper. So that white paper was translated into like 45 different languages in the world. I also worked many years with Extron and AudioQuest, heading the product development. So I've been in the industry for a long time. The Lux Electronics, as I mentioned, is a manufacturer. We invented HDMI locking connectors. You guys probably are using that in the field already, right? You see the locking springs in the front end. You can plug into the female side without requiring any screw or tie to it. So that's our invention. We also invented the field termination. You can put on the HDMI end to the bulk wires after you push through the conduit in 2 minutes. Very simple. You can crimp that down. We also invented the presenter product line, which can do the matrix function without the matrix. You just have 1 small transmitter, 1 small receiver models. You can daisy chain as many as you want. Then that daisy chain is a matrix system. Also, we're working on a new XDI format. That format can send 8K video to 3,300 feet away on copper cables. And we have a prototype matrix showing in our booth. It's like a cigarette pack, very small, which is a 4x4 matrix. So that's the end of talking about myself and the company. We jump to the main topic from now. Okay, are these familiar to you guys? All kinds of problems, no signals, no pinkish screen, wrong aspect ratio, overscan, all those audio popping. All these problems we see in the industry day in and day out. Can any of you guys say you know exactly what caused that, how to fix it as of now? Kind of, often you go by experience, right? We'll talk about why that's the case. So here's a classic HDMI puzzle. I'm sure you guys all experienced this. So in a system 1, you have the device A, B, C. You hook up together, system does not work. What do? You replace the device B with the device M. Now system works. So by common logic, what's the logic you would draw? B is no good, right? But in the next job site, you have the A and M and the C working in the other classroom or home. You are not working. You remove the M, you put back the B, it works. You guys experience this? Yes. So this defies logic, right? Also, when you return the so-called defective products to the manufacturer, 9 out of 10 times, what do they say? It's fine. Okay, so is somebody lying? Luckily or unluckily, not. This problem is actually caused by HDMI specification itself. I get permission for saying this. So this is the first time you heard this? Okay, so we'll keep that in mind. It's not anybody, not you guys' fault, most likely not manufacturer's fault. It's more like specification itself is not written for what we're doing. So keep that in mind. So by the end of this session, we're going to bring up the same slides again. By then, you will say, oh, you understand exactly why this happens. So keep that in mind. Okay, anytime you have questions, raise hand and we'll discuss that, okay? Let's go over some HDMI basics. The basics really help us to understand the why and how, those kind of questions. So this is what's inside the HDMI cable. How many conductors or wires inside the HDMI cable? How did you guys know that? Oh. There are a lot of wires. Okay, there are 19 conductors. Sounds a lot, but it's very easy to remember once you group them together. There are 4 twisted pairs called TMDS. You don't have to remember the name. 4 twist pairs inside. Each twist pair has 2 conductors, and each twist pair has a ground drain wires. So each pair has 3 conductors. 4 of them, that's 12. So 12 of the 19 conductors are the twist pairs. Those are the ones sending the high-speed audio and the videos. Okay, so that's very easy. I'll give you an example why we need to understand how it works inside the skin to understand. So I just said those 4 twist pairs are sending digital audio and videos. How many times your customer call you back say, oh, your HDMI product does not work. I have the sound, I have the video but no sound. Remember, the HDMI send audio and the video together in those 4 pairs mixed together. So if you get video, audio is there too. The reason you don't get audio is some other settings or handshaking we'll talk about later. So just by that one sentence, the audio and the video are sending in the 4 twist pairs already can help you guys to resolve the technical issues. Then the rest of the wires, they're the 5 volts. That's the one to power up the downstream devices. And the CEC, you guys use that to control the TVs, right? Turn on, off, all those. And also, there are DDC 1 and 2. There are 2 DDC wires. DDC stands for display data channel. So those 2 little wires cause 90% of the problems. We are going to focus that 2 little wires for 1.5 hours today. That's 2 little wires. That's so important. Okay? And we have other clock pairs and HEEC, that's the Ethernet and audio return channel. We also have the PD, that's hot plug detection. So when you plug in the devices, then the display will tell the source, hey, I'm a 4K monitor, 16:9 ratio, and 4:4:4 color. Send me the right. So that communication starts with a hot plug detection, connect the 2 devices together. Okay, so 19 wires, only 2 of them we need to discuss today. That's called DDC. That's another drawing of the same 19 wires. We just look at it from the physical side. So this shows you the 4 twisted pairs sending the high-speed audio video data. And the middle one is the DDC. We are going to focus in the next 1.5 hours. Then the CEC utility, it's also the audio return channels, and also hot plug detection. So that's another view of how HDMI works, many cables. Any questions so far? Okay. So starting at the HDMI 2.1, any of you guys already started using the HDMI 2.1? Yes? Okay. The 2.1 looks the same as 2.0. From outside, the connector looks the same. Cable appears to be the same. But there's one important difference. The 4 twisted pairs before, 3 of the twisted pairs are sending digital audio video. The 4th one is sending the clock. Starting 2.1, all 4 pairs are sending high-speed data. And each pair sends up to 12 gigabits per second. You times 4, that's 48. That's where the specs come from. Okay, so that's the main difference. So HDMI 2.1 cables is backwards compatible with HDMI 2.0. Okay, any questions with this? Okay, I will move on. You guys are very seasoned. This is HDMI type A, B, C, D, E, all kinds of connectors. We use A most likely in our industry. A, B, C, D, E is the one with the locking, which can be used in automobile. This shows you, answer your question. That's the history of the revisions. We're on 2.1 now. We introduced a category 3 cable. That's so confusing with the IT world. We're in Cat 8 now, right? So we have Cat 3 in HDMI and 8K compression, like I said. And also those twisted pairs are called FRL now, not the TMDS. Is that raining? Okay. Okay, the 2.0 is already a few years behind us. Do we need to go through what's new for 2.0? Should we jump to 2.0? Okay, we can skip this one. 2.0, what's new? We now support 8K 60 Hertz or the 4K 120 Hertz video. We also have dynamic high dynamic range HDR supported in here, Cat 3 cables, and also the eARC supports many objective-based audio, like Dolby Atmos. Dolby Atmos is not per channel based, it's objective based. It shows if a bird is flying here, we're not sending multiple channels, how loud each channel is. We're sending a reference or coordinates. Then the producer at the receiver end will reproduce a sound image right at this line. That's objective-based audio. We also support higher refresh rate for gaming. Also available with auto low latency mode. In the low latency mode, you basically give all the bandwidth with the cable and the hardware for video, so you maintain a low latency. Why there's latency? Compression. There's compression in it. Any questions with 2.1? Okay, this is not our focus. We'll move on to those 2 little wires. Analog behaves like this. When you go further distance or more copy generations, the quality gradually degrading. So this is bad because once you leave the source device, you never get 100% quality. You guys know that, right? It's also very good. Why many people like the analog devices? Because no matter how long the cable is, how many copies you make, you always get a picture. Even the picture can be only 10%, 20% quality, you always will get something. Unlike the digital, it's called cliff effects. Many people know this already? Okay, that means within a certain range, you get 100% beautiful picture. After a certain range, all of a sudden you get nothing. That's why, remember the reporters early years, they use a short cable, 2 meters. They tried good and bad cables. They look identical because they're all on the cliff. Okay, so cliff is very easy to understand. How many people are from Florida? Have you guys seen the cliff before? I remember when I taught this class in Netherlands, I had difficulty to tell them what is a cliff because Netherlands is so flat. Okay. Here's another basic. You guys can just take a picture of that. We don't have to discuss too much. This shows you the resolution versus file size. If you use certain video, how much throughput, how much data rate you need. For example, the last one, the 8K 60 Hertz, you need 66 gigabits per second bandwidth to send an uncompressed video. You look at the third from the bottom, the 1080p, it's 4 gig. So from 4 gig, the 1080p, you jump to the 8K 60 Hertz, you need 16 times more bandwidth. That's the challenge you guys will face in the next 2 years or so. Your customer insists, I want beautiful 8K in my meeting rooms or in my bedrooms. You guys will struggle to how you're going to connect the system together. 16 times more bandwidth. I also teach another video class. In that, we'll go more in depth. There's actually Lew's law number 2, which is named after me. It says, when bandwidth increased by 16 times, the maximum length for the cable you can run shrink by 16 times. So remember, in the 1080p days, you can run the passive cables to how many? 50 feet or 60, 70 feet. Now you can run 1/16 of that. So that's what's waiting for us in the future for the 8K. Okay, that's a different class. Okay, so you guys have a concept, right? Okay. This also shows you sometimes we are going too extreme or too excessive. Can I ask a volunteer to do a very simple demo for me? Anybody? Okay, come in. Thank you. Can you see the little pixels on the screen? The little small dots?
Yeah.
Okay. You want to jump down to move further away until you, you cannot see that anymore. Yes. Thank you. Right there. Okay. So I'm going down with you. Thank you. That's all. Thank you. So what we just did is to find out what's the optimized or critical viewing distance for any resolution on any screen. So this is the optimized viewing distance, which means if I go further or go closer from here, what do you get? You see the structures of pixel, which is not smooth. That's not desired, right? If I go further away from here, what do you get? You cannot see all the details. So this is a 1080p screen, right? Looks like this is a 1080p screen. So that means for this application, here is where I need 1080p. If I double the distance to where the camera is, I only need a 540p. You guys see the point? Why are we introduced 4K and 8K? We have to use all the hardware bandwidth to run all those problems when people there cannot see the details. Okay, just give you a little bit. So if you have a challenge of making the 8K transmitting for long distance, do this demo to your customers. Let them understand they don't have to pay 8Ks for this kind of application. Okay. Let's look at the last line. If you have 8K 100-inch, which is pretty big for home, the best viewing distance is 3 feet. You cannot even sit down on a couch and hang your legs, right? You have to stand in front of the screen to watch it like that. Okay, just to show you some examples. Okay, now we jump to the main topic. We need to memorize 4 acronyms. The first one is HDCP. is high bandwidth digital content protection. How many of you guys thought that HD stands for high definition? You thought that for high definition. It's very important to know it's not for high definition, it's for high bandwidth digital. Remember 15 years or so, there was a lawsuit. Some manufacturers was trying to forbidden the set-top box to send out HD in analog component video. Any of you guys remember that? You remember that? Yeah. And later, the judgment was you cannot do that. You cannot add copy protection to that. Why? Because HDCP only governs digital signal. If you have an analog high definition, no problem. So you can convert to analog VGA high definition and not subject to HDCP. So keep that in mind. Okay. And the EDID, you guys probably read as EDID, right? Yeah, that's the extended display identification data. So you guys already know this pretty well. The third one probably not well known. The third one is that two little conductors we just saw earlier. That's the display data channel, basically the two wires. That's the DDC. The last one probably will be even few people heard this before, I2C. I2C is a protocol dictate how the signal is sending through that two wires. I2C basically is inter-integrated circuit. You put IIC together, the two I's together, you put the I square. So it's called I2C. So just from the I2C name itself, what did you see? The I2C is designed for two IC chips on the same board talking to each other. That's how the Philips developed I2C4. We are now stretching this system with 100 meters cables in between with multiple devices in there. That's what I said in the beginning. The standard for HDMI to choose I2C to manage the DDC, I'm not sure it's wrong or for nearsighted. That's the root cause of most of the problems we see nowadays. Okay, now you guys see why this happened. Look at the 7 companies who founded HDMI. Silicon Image is an IC manufacturer. The rest of them, Philips, Sony, Panasonic, Hitachi, what are they? Most of them are Japanese TV manufacturers. And Japanese market, as you know, they have a very small living room. The TV is on the wall. The set-top box is right under that with a 1 meter cable. They don't have a professional industry like we do to send long distance or that. So when they develop that standard, they don't know there's such an application like this, so they pick the I2C. Okay, any questions with this? Okay. So these 4 words, if you feel it's difficult to memorize, I have a graphical memory. So normally a picture tells you more than 1,000 words. So that's how you remember that. The DDC is the road. It's a one-way road for the car to go through. And the HDCP and EDID are the cargoes on the cars. The car carry them over. You notice the 2 cars are heading to each other on a one-way road. That's called a collision. So all the problems that you see is the data collision. And I2C is the one who will govern this road. That happened to be a blind policeman. Okay, now you guys have an idea of what's going on, right? Okay. Let's go with the first topic, HDCP. HDCP, the specification is set by Intel. Intel manages the specification. It protects the digital contents. It's a source managing display. Like I said before, the source will tell the display, hey, this is what I need. Then the display will send what the source will send what display needs. So remember the communication is from the display to the source. It has 3 functions. One is authentication. When you just plug in them together, the source device will ask the display, hey, are you HDCP certified? So they're asking for a key. Then the display will send the key, the source will look at it, then give yes or no. If no, you don't get pictures. You guys connect HDMI through an adapter to a DVI monitor, what happens? No picture, right? Because DVI is not HDCP certified. So the HDMI would refuse to send content to the DVI monitors. The second one is encryption. So after they verify the keys, then the video signal is actually encrypted. It's not straightforward. It's a very complex algorithm encryption in there. And this encryption changes every 2 seconds. So every 2 seconds, the method of encryption changes, and the two devices will exchange the decryption keys so the display can continue to decrypt the signal. How many times you guys see the image flashes in a 2 second interval? Yes, yes, okay. Now you know if you see a 2 second interval flashing, it's HDCP related. Okay. Okay, you saw flash and cut, that's very good. That means the key authentication takes longer time. So they actually send the signal once, then later discovered, then it cut. Okay. The third function is revocation. That means if certain keys get compromised, the source would refuse to send signal to that device permanently. This probably you guys don't see a whole lot, but it's actually written in the standard. Do you guys know this the blacklist grows all the time? If they found more keys being revoked, they add to the list. How do the manufacturers send this growing list to your Blu-ray player? Do you guys know? How the Blu-ray player in the old days has no internet access, right? How do they update the blacklist? Yes, it's on the disk. Every time you buy a new movie, the disk actually has a new blacklist listed in there. Yeah, so if you want to preserve your TV, which is a blacklist, you just refuse to buy new disk, then it should be fine. I'm not sure that's a solution. Okay. This is a little bit complex. We don't have to go through details. Just to let you know, the HDCP has layers of management. It can manage up to 4 layers. So it's like a VP manage a director, director manage a manager, manager manage the supervisor, and supervisor manage everybody else. Okay, so HDCP has that layered management too. And normally, the lower layer does not report the condition to the top. You only report to the immediate layer above you. Okay, keep that in mind. So this actually explains some of the time, for example, this splitter, HDMI splitter. When you hook up multiple displays, there's no more signal. Some people explain that as the splitter running out of keys. That's actually not the case. There's no limit on how many keys that splitter can have. Okay, just give you a little bit idea. This one we can skip really quickly. That shows how the handshaking encryption happens in this sequence. We don't have to go through the details. We only need to know the more important thing afterwards. Oh, there's another HDCP locality check. So starting the HDCP 2.0, the HDCP not only manage the local wired content, HDCP also attempt to manage the wireless and the whole worldwide internet. Remember, I added the word attempts. So when I came to US, one thing struck me was like NBA finals. You call that world champion. It's obviously a US champion. This year it could be a Canadian champion, but it's not world champion, right? Yeah, so with HDCP 2.0 and below, when you manage your local network, it's just like a nation champion league. It's much easier. When you jump to the worldwide, like internet stage, it's much difficult to block the hackers. So the HDCP 2.0, within a few months of its introduction, when nobody is actually making product yet, it's hacked. Because now people can use the internet sitting in the north or the south, can hack you from far away. You are dealing with worldwide hackers. So the HDCP quickly changed to 2.1. So the 2.1 is not backwards compatible with 2.0, not backwards 1.4, and it's a hardware change. You guys probably noticed this. The manufacturer had to change the board for that. Okay, that's the locality check. So when you try to manage the larger, then it's more difficult. Encryption, we can skip that. We mentioned that earlier. Okay, the HDCP 2.2. This is required for 4K and higher resolution content. And required for every device in the chain. So you cannot have mixed device like a 4K display, but it's a 1080p receiver. That's not allowed. So once that detected, the 4K content will be turned off. And I also mentioned it's a hardware change. No firmware update can fix this. Okay, EDID. EDID is governed by VESA, the Video Engineering Display Society. And HDMI added more by CEA, more data of the EDID because consumer has audio standard and has other display format. It's a display managed source device. The data contains, have you guys read any EDID? It's like a few pages long. It shows you manufacturer ID, color, all those, and audio format, all those stuff. Okay, so we don't have to spend too much time here. Okay, all the previous data, HDCP and the EDID data, are sending through those two little wires, the DDCs. Okay, and how they are sent? They are sent by the I2C. So I2C is invented by Philips. It's a beautiful system for what it's designed for. What is it? Imagine a circuit board with many IC chips. You only need two wires to loop them through. Then every chip can talk to each other and with no collision. How beautiful is that? That's two-way communications. That's a beautifully designed system. It's a low speed in there. So you can hang on all those controllers, the gateways, all those microcontrollers in the same two wires. Very beautiful. How does the I2C manage the collision? You have so many devices on the same line, right? How does it manage that? This is a little bit difficult, but I'll use verbal description so you guys don't be scared by the chart. So every time for a device to start talking on that line, the device will listen first to see if the line is open. So when line is open, then that device starts sending the data. Also, there's a second confliction management. If this device is sending a logic 1 signal, then after sending logic 1, he found out that line does not follow him. The line still stays in the logic 0. Then this device knows somebody else has a higher authority is using this line. Then this device will give up. So this is a very beautiful conflict and very simple conflicts management too. So by doing so, you have many hundreds of devices in the same line and no conflicts. Don't you wish all the countries in the world resolve the conflicts this way? Yeah, so it's a very beautiful system. But the trouble is, for this system to work, you need to have no delays. Because if you have a long lines with long delays, for example, if you start talking, your signal has not reached my point yet. So when I listen to the line, I say, hey, it's open. But at the time, you already start talking. So when I talk again, you have conflicts. You guys have this experience with a voice over IP or the international phone calls? Yeah, you pick up, you say, hey, Joe Lee. Then the other side, hey, Lao Wang. Then you guys are very courteous people. I believe that, professional. You are not cutting other people off. But with the delay in between, then you would have conflicts like that. because you cannot hear the other side at the moment he starts talking. You have this experience, right? Okay, so here comes the problem. Why we have I2C problems within HDMI? The specifications say the capacitance with all the cables and devices cannot be more than 400 picofarads. You don't have to remember the number, just know there's a limit. But what problem we have? A 25 feet cable has bigger capacitance than the standard requires. How many of you guys install over 25 feet? Yeah. So that means majority of the system we install in our industry are illegal.
I'm sorry.
Have you guys heard this before? Yeah. So because any physical cable longer than 25 feet, the capacitance is more than 700 picofarads. We are over the limit. It's over what the I2C is designed for. That's the root cause of all the problems we have. You use HDBaseT, that's 3,000 feet of cables, right? That's 5,000 picofarad of the capacitance, way over. You guys notice sometimes it happens with that, right? So when you have a long delay in between, then devices cannot know the line is already used by another remote device. Then they talk at the same time. That's called a collision. The one on the right is easier to resolve. You have insurance. Okay. So remember this chart we showed before? The I2C manages the all-important HDCP and EDID data. And they are subject to collisions. And it's a sure thing because we use too long a cable in between. Okay? You guys see the problem we have?
So how big a difference are there in the cables?
How big a difference in the cables? Cable is physics. So for cable to maintain the 100 ohm impedance required by HDMI, that capacitance per foot is virtually a fixed number. So there's no magic to reduce that capacitance. If somebody claimed they resolved that issue, most likely it's lying. So cable longer than 25 feet will be over the specs. And most of the systems you guys do are over 25 feet. Why don't you have 90% failure rate? I'm waiting for somebody to ask that question, to challenge what I'm saying here. That's a logic, right? If most of the system is beyond the specs, why we don't have failures in every system? Say it again? Collision detection in the protocol. That's a very good, I wish you were in the committee 15 years ago to write that into the specs. It's not there, unfortunately. I2C itself does not have I2C has collision corrections, but that's based on short delays. When you have long delays, it does not work that way. I really wish something is written in the beginning. Why? Now go back to the same analogy I gave you guys on the internet phone calls. Okay, so when you call, hey John, the other say, hey Doe, then you found out you have a collision. What do you do next? You wait. That's the key word. You wait. You wait like a few seconds, make sure he's not talking. Then the other side also waited. Then if you waited 5 seconds, you start talking again, and the other side waited 7 seconds, problem solved. You talk first, he listened to you. What if he waited 5 seconds too? Then you will be collided the second time, right? That's exactly happening, don't laugh, it's exactly happening in our system. Because, I'll show you. Okay, so all the problems we see before is a result of data collision. When you have no HDCP or EDID, you will have problems. So why we don't see that so often? The funny part is, when you have a collision, then software detects something wrong. The data is corrupted. What will do? The software will have a timer. I wait a few seconds, then we'll try to communicate again. So if Panasonic has a timer of 2 seconds, Sony has a timer of 3 seconds, it's beautiful. The collision will be eliminated in the second try. But the trouble is, many software engineers, they choose 2 seconds timer. So you will have a second collision again, then you have a third one forever. So when that happens, you have no picture or you have a wrong picture. So remember, when you have a delay, you have collision for the first time. But if you have a timer which makes your second attempt different from the other device is trying to do, the second communication will be a success. Then you would not see a problem. You only see problem when you have a long delay and the two devices is trying to do the re-communication on the same interval. Does this make sense to everybody? This is very important. We need this concept to solve the problem in the next slide. So anybody have questions? Try to ask. Okay, you get the concept, right? Okay, so to make it more visualized, I came out with this analogy. Imagine you are throwing in a dart onto a target. So only when you hit the bullseye, the system fails. It's reverse logic. So when you hit the bullseye, that means you have long delays, and you have two devices attempt to talk at the same time, and they try to delay the same amount of time, try to talk a second time, continuous failure. So this condition, we call it you hit the bullseye in a bad way. So this means if you hit the bullseye, then the system would not work. Are you able to duplicate the system in your lab first to make sure it's working, then move this system to a customer side, and it will work again? Not necessarily. You guys have similar experience? Because in the system, customer side, most likely you are running a different cable, different make, different length. Also, the customer will plug in a different AC outlet. Your power sequence may not be the same. In your lab, you can turn on ABC device with a flip-up power and a CD device with another flip-up power. So they start talking at a different timing. But to the customer side, they may all turn on at the same time. So you're not able to duplicate this ahead. So you cannot prevent this from happening. So what do we do? The manufacturer cannot avoid this because that's the way it is. What do we do? So this analogy gives you a very simple and beautiful solution. If you have a target, your dart hits the bullseye, you only need to move the target anywhere, then that dart will not hit the bullseye anymore. It makes sense, right? You can move the target up, down, left, and right, any direction. As long as you move it, it won't hit anymore. So translation, if you have a system problem with the HDMI, you just change any device, any cable in the system, most likely the system will work again. Do you guys have this experience?
And does it stay consistent?
It's quite consistent if the cause of the problem is like this. Yeah. So when you change any device, for example, the Blu-ray player or a cable, you change the timing. You change when the device starts talking or how much delay for the device to do a second talking. So that most likely would avoid the collision. I have this experience. One time I was in Germany. The shop owner was very unhappy because our distributor sold the HD-based TV to their, they have all the TVs, they're all blank, no pictures. So the shop owner just refused to listen to our engineers' explanation what could go wrong. And he even refused us to go to the job site to troubleshoot. So while he's arguing with the engineer, I went there, I unplugged the HDMI source device from a Panasonic to a Pioneer. All of a sudden, all the 60 TVs has pictures shows up. The owner asked, what happened? What happened? What did you do? Then I explained there what I did. So by doing a switch, simple switch to make the image showing up, the owner opens up his mind. He's not so kind of sure it's our problem. So by doing that, we earn the chance of talking to the customer to troubleshoot what's wrong. So you guys do this. If your customer is screaming of the problems, ask them to do a simple change. Anything they can change from a laptop to a Blu-ray or to a set-top box. Once they see a picture, they know all the hardware in there is actually working. They just need to give you time to troubleshoot the rest of the problems. Okay.
Is the difference in changing the quality of the cable, can that impact the problem you're having?
Yeah, the question I'll repeat. Can you change the quality of the cable to resolve this problem? Most likely it's no, because the capacitance is physics. So for 28 gauge cable, you want to maintain, say, 100 ohms. That conductor size and the distance between two conductors in the twisted pair is fixed. So the capacitance is fixed. So the good quality and the bad quality cable will have a similar capacitance. So that would not change. But by changing the cable length would work.
I'm going back to the picofers, the length of the cable run.
Yeah.
I was wondering if in the length of the cable run, a video matrix counts as part of the length, or that counts as a termination end and then out to the output.
Okay, so the cable run, once you have a matrix in between, do you count the total length or you count the one before and after the matrix?
Count the length to the matrix?
Yes.
Count the length from the device to the final output?
Okay, so when you count the cable length, you count from the source device all the way through the matrix to the display, or you count from source device to matrix and the matrix to display. Depends. Depends on if your matrix has reclocking. If your matrix has reclocking, you count from source to matrix separately from matrix to displays. If the matrix is a simple physical switch without reclocking, you count the whole line. Okay. So this actually opens up, now you guys understand what we had in the beginning. Remember that puzzle? So in the system 1, when you have A and B and C together, it did not work. Now you change the B to M, it works. It's not because the B is defective. It's because M and B has different timing. Is everybody with me on this?
So two exact TVs are going to have different timing?
The question is, two exact TV will have different timing? No, they will have exactly the same timing. So same model, same manufacturer, most likely it has the same timing. Yeah. So now you guys will be easily understood what we talked about before. So now you put the so-called the bad B product into the system 2, it works. Why? Because of the timing combinations. Okay, is everybody clear?
So, sir, using Redmere chipset, don't even understand how it is resulting in it, but is that somehow, is it changing the clocking between them?
Yeah, the Redmere chip, your experience by using the Redmere chip, sometimes you fix the problem, right? Yeah.
We've gone 100 feet with a Redmere chipset.
Right. Actually, that's true. When you added the Redmere chip to that, the problem resolved. But if you add a Blackmere chip in there, it will be resolved too.
I'm just saying, like, is that all? I'm just asking, that's the only chip that I know of. I'm just saying, is that changing the timing?
Yes. Yeah, the Redmere reclocked the signal. Yeah. Yeah, so basically, luckily, it's a very difficult problem, but luckily, you can change many things to make it happen. Okay, so now we understand actually not any devices in this example is defective. It's just the timing issue. So what do we do? It's very difficult to change an 8K screen. That's the most expensive device in the system. Customer would refuse to let you do that. It's difficult to change the cable too. More likely it's in the wall, right? And it's probably relatively easy to change the source device because it's standalone and relatively not too expensive. But the customer may insist every device in the system must be Samsung. What do you do? Okay, so we can change stuff sometimes. We cannot change all the time. So what do? There's some kind of device like this in the marketplace. So this device looks very simple. There's a HDMI input and HDMI output. So by looking at just the form function, this product does not look like it's doing anything, right? What it does, you guys can take a guess. Change the clock, exactly. So this device inside has two microcontroller portions. One talk to the device upstream, one talk to the device downstream, so they isolate the communication. Also, we'll assign a different read timer clock to it. So when you add this device to it, the initial collision would be avoided. So this is just a simple inline device. You plug in, fix the problem, and leave the job site. Yeah?
Does it make a difference which HDMI version that adapter was constructed under?
The question is, does the HDMI version make a difference in the problems, right? Yeah. Okay.
With that adapter?
With that adapter, does not. Right. The DDC we just talked about is independent from the HDMI main spec itself. Sure. So DDC is managed by I2C. I2C has not changed since the HDMI 1.0. Thank you.
So would that stay plugged in, or you use it once and then it's done and you walk away?
A good question. Will it be plugging permanently or use once and remove? Unluckily, you need to leave that in the system. So that leads to the next question. Who's paying for that? You normally, right? You guys are installers, I can tell. Yeah. Professors will not laugh at this moment. Yeah, so you already give the quote to the system, customer already approved, and you install everything together, it did not work, then you need this device. For dealer price, say $70, $80, who's paying for this? The customer will definitely not pay for this, right? So the solution we found out as a businessman is we did a lot of statics with our customers. We found out 1 in 7 or 1 in 8 systems, you run into this kind of timing issue. So if this device is $70, $80, you divide it by 1 out of 7 or 1 out of 8. So each time when you give the quote to the customer, you add $10. Be creative, service fees, whatever fees added to that. So each job you add $10. By the time you use this, just leave there without saying anything, just leave the job site, and you are paid for. Right? Without this, think about it, you need to call the manufacturer. You need to leave customer's job site. Customer, what's going on? It said you don't know. You go to the office, you call the manufacturer. Manufacturer said return the product. You go to job site, grab the product, you return. Then manufacturer 2 weeks later say no trouble found, return to you. Then you go to customer site the third time and it doesn't work. Then you change to something else the fourth time. The labor is not worth it. So just leave there without saying a word, and you are paid for. Is that something you guys can use? Say it again. I couldn't hear what he said.
Does Blue Engineering sell this product?
This is a manufacturing neutral show. We can now say that. But you guys can find out in the marketplace. Okay, the question is the signal repeaters in the marketplace, would that work similar to this? It's not nearly as effective because signal repeater normally only make the signal bigger, equalized in that. Does not actually change timing too much, so it's not as effective. You guys also saw some product called EDID fixer or recorder in the marketplace, right? Those products also function different from this. What does that work? That product is when you probably use that, you use that device to connect to the display first to record the EDID. Then you remove that device, you put that in the source device and play that back to the source device to force the source device to send out certain resolution. Is that how it works? Right. So remember we talked about the EDID is a handshaking once when you power up. So for EDID, it works. What do you do with HDCP? Remember HDCP, we talk about every 2 seconds we change keys. Unless you are Incredibles, you run to the source device, record that, run to the display, every 2 seconds, like that, you can get it work, right? Otherwise, it would not. So EDID minder or fixers can work with a DVI, which has no HDCP, but would not work with a HDMI.
So do these collisions happen between the same manufacturer, transmitter, and receiver of HD-based TV, or is this on the HDMI side?
Repeat the first sentence, I did not hear it.
So do the collisions or the delay
Uh-huh.
timing happen between the same manufacturer of transmitter and receiver over HD-based TV?
Yes.
This line of obviously an HD-based TV.
Right. The question is, does this delay happens with the same manufacturer's transmitter receiver? Yes, it happens there too. So when that happens, you try to change the timing after the receiver or before the transmitter. You can still do that. We found out it's more effective between the receiver and the display, somehow.
I think he was referring to HD-based T, where you can do it over CAT. He's saying
Right. This cannot do with HD-based T. We have no CAT connections here.
he's saying like, does that still happen?
It still happens. It's actually one of the biggest source of this kind of collision.
Well, how come the manufacturer doesn't know the timing of their endpoints?
Well, the question why the manufacturer does not know the timing of their endpoints, they cannot do a thing because when you have 3,000 feet cable in between, that 3,000 cable has 5,000 picofarad capacitance. That's physics. They cannot change.
But can't they set the two to different rates no matter what? One listens for 2 seconds and one listens for
Okay.
7 seconds.
A very good question. Right. So you're talking about the transmitter and receiver setting to different timers so they avoid this. You can do that. The main problem is the receiver will have a collision with the TV. That's out of your control. Okay.
I hear you say earlier if you change the length of the cable, you'll be able to solve the problem too.
Yes. The question is, can we change the cable to solve the problem? Yes. But you need a significant change. It's not like a 1 foot or 2 foot change.
What's the minimum change?
We're talking about maybe 20 feet, something like that. Remember, 25 feet give you the capacitance over the limit, so you need to make 10, 20 feet changes to fix this. So by shorten 10, 20 feet, most likely it's not possible, right? You cannot reroute the cable. So to add 10, 20 feet, that's a whole bundle of cables. It's an eyesore too. So that could work, but not ideal solution.
With the scenario different between the fiber optic HDMI AOC and traditional copper cable?
Okay, the question is AOC, fiber optics, would that have the same problem? Yes. AOC, as you guys know, send the audio video signals through the fiber, through lights. But the DDC is still sending through the 2 copper wires. That's why it's called AOC. It's a hybrid, a mix of that. So AOC actually is worse in this scenario because AOC is long, 300 feet. So the 300 feet copper in there will cause more delays. Does it make sense? Yeah, the AOC use copper to send DDC, not fiber. Okay.
Would there be any sort of difference between using an active or passive HDMI cable?
The question is, will there be a difference between active and passive cable? Yes. The active cable, because some chips will retime the clock, so that will change the timing also. But some chip does not retime the clock. Like earlier Redmer chips does not retime the clock. I'm glad everybody bring all kinds of scenarios for us to discuss. Any other questions? Okay, so Now we have a little troubleshooting session. So we know HDMI can go wrong if the cable goes too long because the high frequency signal get attenuated. That's the cliff effect, remember we talked about earlier? Some HDMI problem is created by the handshaking or EDID on the DDC copper wires. So how do you troubleshoot between these two? Because they require completely different fix. So if you have a system, or say without a picture, remember inside HDMI cables, the 4 twist pairs and the 2 DDC wires are physically separated. They have no relationship whatsoever. So the audio-video signal is sending through the 4 twist pairs, and the DDC is sending through the 2 DDC wires. They are physically completely unrelated. So this gives you a way of troubleshooting. If you have no picture, even you can do this over the phone. First thing you do, you ask your customer to bring the source device next to the display with a short cable in between. Let them play to see if they get a picture. So number one, you make sure these two devices are compatible with each other. If they are not compatible with each other, you're adding more cable in between. They are not compatible, right? Then you ask the customer to bring the source back to where they are, the source device. Then very simple, ask them to lower the resolution by 1 click. So if you are running 1080p with no picture, you ask the customer to turn to 720p. So by doing so, if the picture comes up, you know the problems he has before is bandwidth related. If still no picture, more likely it's DDC related. Make sense? Yeah, very simple logic because they are not relevant to each other. So let me repeat, lower the source resolution by 1 click. If you get no picture still, then the problem more likely is handshaking issue. If you get a picture come up, it's the bandwidth issue.
Another also, pretty sure everybody knows this, is that don't mix your monitors.
Resolutions.
Resolutions, don't mix them with high,
Okay.
Example of 1680 by 720 with
Right.
1080. Because if you put them all, they're going to either
More issues to come out. Yeah. The same, yeah. Very good point. So try not to mix the different resolution in the same system.
always
Yeah.
check on their max resolution.
Right. So with a very simple troubleshooting you can do over the phone, if you determine the problem is bandwidth related, there are plenty of pigtails like this in the marketplace, which is called equalizer or booster or amplifier, which can make the signal bigger. If you determine the problem is related to the HDCP, then the other little dongle can fix the communication problems. So the suggestion would be have you guys or your own techs to carry one of each in the briefcase all the time. Whenever they need, use it, leave on the job site, and move on. That saves you a lot of labor time and troubleshooting time. Is it simple? Clear? Okay. So, any more questions before we go to the summary? The 2 little wires out of 19 conductors inside HDMI are called the DDC. They carry the copyright and handshaking signals. The I2C is the protocol managing the data. And we exceed the I2C limits. That's why we have all the problems. The problems can be easily resolved by changing the timing. Is that very clear? Any questions with what we have here? Okay, and so if you guys have more questions, you're welcome to contact InfoComm or get a copy of the PowerPoint, or here's the website or email address. You guys can ask me for a copy of this. Okay, thank you guys very much. hopefully this is helpful to you guys. Thank you.